We all need water. Farmers in California's Central Valley have been using groundwater since the 1920s. As a result, some areas have sunk. Some have gone down by as much as 28 feet. Chowchilla, which is a town located in a basin in Southern California, is sinking because of this groundwater pumping. In fact, 95.58% of the basin's water supply is groundwater. In the basin, or in the area near Chowchilla, there are 1,489 wells, 16 of which are water supply wells. Subsidence is actually known to have damaged wells in the area. And in Mexico, which, as I would hope you would know, is not in California's Central Valley, subsidence has actually damaged some colonial-era buildings, and as someone who loves history, that is kind of heartbreaking. So it's very clear that this is a big problem. It's causing damage. So in order to understand this and to find a way to mitigate or solve it, I think that we need to get a better look at the science of subsidence due to groundwater pumping.
It is also worth mentioning that the Chowchilla groundwater basin declined an average of 40 feet from the year 1970 to 2000. Now, when it comes to the science of land subsidence, it first starts out with rainwater seeping into the ground. So in this case, I use a sponge to represent the little pores and things like that in the soil. And when that gets pumped out, in this case, squeezed out in my demonstration, by groundwater pumping, of course, the land goes down because there is no longer as much water helping to hold it up. In a drought, farmers throughout the valley rely on groundwater, which makes this problem worse. They pump a bunch up. Now, I think we should transfer to my friend, Subsidence Water Waster, to get an idea of how we could mitigate or solve this problem. Hello, this is Subsidence Water Waster with my little clipboard. So today, we're going to be talking more about the Chowchilla Subbasin. Now, the western Chowchilla Subbasin suffered 0.2 to 0.4 feet of subsidence from March 2020 to March 2021. Now, I think would be an excellent time to talk about possible mitigation and solutions. First, we should educate the youth in the area about the problem and its dangers so they can act. So if they know the source of the problem and how bad it is, they have a higher chance of being able to act because of their knowledge. We could also possibly have tax measures and maybe permits for people who pump a certain amount of water, or people who pump a certain amount of water would need those things. Also, cutting water pumpage in many ways would be a start to fixing the problem, because this has actually been shown to have helped subsidence in Taiwan and Japan. Artificial recharge from the surface is also an option. We could pump fluids or other things into the ground in order to kind of get a little bit of uplift. There are also Chowchilla groundwater sustainability projects, such as the Domestic Well Mitigation Program, which installs 9 new monitoring wells in 3 locations of the Chowchilla subbasin. This program works to help us with understanding. There is also a project to try to move to crops that do not take as much water. Things like this could lead to less pumping from farmers and things like that. Also, according to the Sustainable Groundwater Management Act, all groundwater sustainability agencies in high and medium priority basins, which is based on population, groundwater pumping, etc., are required to have groundwater sustainability plans or an alternative. The plans are meant to provide a roadmap to get to long-term sustainability, and it can be expected that these plans will help reduce subsidence. And I've actually been able to find the one for Chowchilla. It was pretty interesting. Ultimately, though, tackling climate change can prevent droughts and reduce groundwater pumping, as we